Chapter 1, Matter in Our Surroundings. In last lectures, we have studied about characteristics of particles and change in state. Now we will continue with the few things remaining in change in state. Now, water can exist in three states of matter. First is solid as ice. You can see here in solid state of the water, that is called as ice. Liquid as familiar water. You can see when ice starts melting, it gets converted into water, and that is called as liquid state of water. And third one is gaseous state, that is the water vapor. You can see here when water gets heated, it gets converted into the vapor. You can see here white color substance that is coming out of the water. Okay. What happens inside the matter during this change of state? What happens to the particle of matter during the change of state? How does this change of state take place? The physical state of matter can be interconverted into each other by following two ways. Now these are the few questions which will arise in your mind when there is a change in state. There are the two ways actually to convert physical states of matter. Let us see that by changing temperature and by changing pressure. These are the two ways to convert state of matter. But when there is a change in state of matter, there will be few things which we have to consider, and we will come to the answer. That is, what will happen inside matter. Second is, what will happen to the particles, and how does this change take place. So all this we have to consider. We'll understand about these things in the later class. In the first one, we will understand about what is temperature, and after that we will move to change in state of matter because of change in temperature. Let us see first temperature and its definition. Temperature is measure of how hot or cold something is. Specifically, a measure of the average kinetic energy of the particles in an object, which is a type of energy associated with motion of the particles. So, temperature is nothing but it is a measure that how the object is. It is a cold or it is hot. And when you increase the temperature or decrease the temperature, there will be change in the kinetic energy of the particles. And as you know, we have studied in the previous class that when you increase temperature, there is a change in kinetic energy, and therefore there will be change in the motion of the particles. Now let us see the units of temperature. Unit of temperature are, first one is degree Celsius, Fahrenheit and Kelvin. These are the three units by which we can measure the temperature, or you can say the amount of heat or cold. This is the device which is used to measure the temperature, and that is called as thermometer. You can see here. Now conversions of unit. Here the most important thing is conversion from degree Celsius to Kelvin. So this is the conversion we are going to study now. 0 degree Celsius is equal to 273.15 Kelvin. How you will get the relation between that is here. When you have got temperature in degree Celsius, you have to add 273.15 and the sum will give you the temperature in Kelvin. But for convenience, we take 0 degree Celsius as 273 Kelvin. 0.15 no need to write for our convenience. First one, degree Celsius to Kelvin. So whenever you have got any temperature in degree Celsius, you have to add 273 to that degree Celsius. You will get the answer in Kelvin. Let us understand with the example. That is 10 degrees Celsius is given. When you add 273 to 10 degree, you will get 283 and that will be in Kelvin. So remember that thing, when you want to convert degree Celsius to Kelvin, you have to add 273 to the value. For Kelvin to Celsius, you have to subtract 273 from the value of the temperature in Kelvin. Here is the example. 300 Kelvin is given. You have to subtract 273 from it. You will get 27. Now let us understand the effect of change of temperature. Now when you change the temperature, what is going to happen to the state of matter? Let us understand with the help of activity. Take about 150 grams of ice in a beaker and suspend a laboratory thermometer so that its bulb is in contact with the ice. Here you can see that we have taken ice in a beaker and we have to put thermometer and the bulb of it should be in contact with the ice. Start heating the beaker on a low flame. Note down the temperature when ice starts melting. Note the temperature when all the ice has converted into water. Record your observations for this conversion of solid to liquid state. So you have to do this when you are doing this experiment, you have to note down this results. When ice start melting, when ice gets converted into water, all that temperature you have to note down in the book. Now put a glass rod in the beaker and heat while stirring till the water starts boiling. Now this glass rod we have put in the beaker and we have to use this to stir the ice till it gets converted into water, and after that if continue heating it will get converted into vapor. Keep a careful eye on the thermometer reading till most of the water has vaporized. So you have to continuously check the reading of the thermometer till the ice gets converted to water and water converted to vapor. You have to record your observation for the conversion of water in a liquid state to the gaseous state. So you have to record this also. So here we have to start recording the readings of thermometer starting from the ice to water and water to gaseous state. On increasing the temperature of solids, the kinetic energy of the particle increase. That we already know. When we increase temperature, kinetic energy of particle increases. And due to increase in kinetic energy, the particle starts vibrating with a greater speed. So the movement of particles becomes random and faster. The energy supplied by heat overcomes the force of attraction between the particles, and the particles leave their fixed position and starts moving more freely. So when you supply heat, that heat will be used to break the force of attraction and to break the force, or you can say to break the bond between the particle, and the particle will start moving freely once the bonds break. Now when the bond breaks, the solid slowly starts getting converted into liquid, and that process is called as melting. Let us see about melting. A stage is reached when solid melts and is converted to liquid. So if you continuously supply heat, actually you can say the particles which are bonded with each other in a solid, it breaks and that gets converted into liquid. The minimum temperature at which a solid melts to become a liquid at atmospheric pressure is called as melting point. So melting point is a temperature, a minimum temperature at which solid gets converted to liquid, and that will be at atmospheric pressure. Atmospheric pressure means the normal pressure. The melting point of solid is an indication of strength of force of attraction between its particle. So this statement is very important. This statement shows us that if the melting point, that is nothing but the temperature at which solid gets converted to liquid, is higher, then the force of attraction between the particles will be more. Suppose if any substance get melt, or you can say if any substance has melting point 50 degrees Celsius and the other substance has 150 degree Celsius. So in this in this substance, the force of attraction between the particle will be lesser, and in this it will be more. The force of attraction between the particles will be more in this. Okay. Now the melting point of ice is 273.15 Kelvin. You can also convert this Kelvin into degree Celsius. You can write it as a 0 degree Celsius. Change of solid state into liquid state on heating is known as melting or fusion. When there is a change of solid state to liquid, it is called as fusion or melting. You must have observed during the experiment of melting that the temperature of system does not change after the melting point is reached till all the ice melt. Now, when you are doing this activity, while you are observing the temperature in the thermometer, you will not find any change in the temperature when all the ice gets converted to water. Once all the ice gets converted to water, you will find the increase in the temperature of water. But till all the ice gets converted to water, the temperature will remain same only. And the reason is here. This happens even though we continue to heat the beaker. This heat gets used up in changing the state by overcoming the force of attraction between the particles. Now, why this happens? When all the ice gets converted to water, after that only there will be a rise in temperature. Why? What happens when there is a ice in? So the ice has this structure. This is the particle molecular structure or particle structure of the ice, and this is of water. Okay, this is of ice and this is of water. When you supply heat, what will happen? These bonds will break. All the bonds will break. Now till all the bonds of the ice breaks, the temperature will not rise. That heat supplied will be used to break these bonds. Once all the bond of this ice is broken down, it will get converted to this type of structure. There will be no connection between the molecules of water. And after this state is achieved, there will be a rise in the temperature. Temperature will increase. Okay, this is the reason why the heat, or you can say the temperature, does not rise during the conversion of ice to water. As, as this heat energy is absorbed by ice without showing any rise. So we have already seen when there is ice, it will gain the heat energy, but there will be no rise in the temperature. It is considered that it gets hidden into the content of the beaker, and it is known as latent heat. Okay, the heat, the word latent means hidden. It will not be visible. You'll be thinking, even if we are continuously giving heat, why the temperature is not rising? That heat gets stored in the form of latent heat. It will be hidden, and that hidden heat, what is the work that hidden heat is doing? It is breaking the bond of the particles of the ice. Okay, the amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion. Now, latent heat we have already understood. That is nothing but the hidden heat. It is hidden. Now, fusion, that also we know. It is nothing but conversion of solid to liquid on heating. Here, amount of heat energy which is required to convert 1 kg of solid. It can be anything. Here let us consider ice. 1 kg of ice which is solid to convert into liquid, that is water. And atmospheric pressure. At atmospheric pressure means the normal pressure which is right now in the room in which you are sitting. That is called as atmospheric pressure. Pressure of air. Actually, at its melting point, and this all conversion will carry out at the melting point, and the amount of heat energy required is called as latent heat of fusion. Okay, so the particles in water at a 0 degree, that is 273 Kelvin, have more energy as compared to the particles in ice at the same temperature. So when the particles which are present in ice and the particles which are present in water during the change of state, that is this solid to liquid, water particles will have more energy. Why? Because ice has lower temperature. Actually, ice have the particles which are bonded, and water have the particles which are not bonded. They can move freely, and we can know that when you provide a temperature or when you provide a heat, the particle gets kinetic energy. Okay, and that kinetic energy helps the particle to move faster. So water which is liquid has more energy, which is because of the temperature. That is, water at 0 degree has more energy because particles of water have more space, they can move freely, whereas ice, the particles are bonded and they do not have much energy to move. Okay. Effect of change of temperature. When we supply heat energy to water, particles starts moving faster, right? At a certain temperature, a point is reached when the particle have enough energy to break free from the force of attraction of each other. Now, when you continuously provide heat energy to water, the particles will start moving faster and faster, and one point will be achieved at which you will have enough energy to break free from the force of attraction of each other. And at this temperature, the liquid starts changing into gas. So, when the water achieves the enough amount of energy, the force of attraction will get reduced between the particles. And when the particles has less force of attraction, they will start moving freely, and therefore there will be change in the state, and slowly liquid gets converted into gas. Like in previous case, ice started melting and got converted to water. Here liquid will get converted to gas. Now the state which is converted into gas is liquid, and when there is a liquid to gaseous change of state, it is called as boiling. The temperature at which liquid starts boiling at atmospheric pressure is known as boiling point. Like in melting, a minimum temperature at which solid gets converted to liquid called as melting point. Here, when liquid get converted to gas, it is called as boiling point. And boiling is a bulk phenomena. What is the meaning of bulk phenomena? It is nothing but particles from the bulk of the liquid gain enough energy to change into vapor state. Meaning, many particles at the same time will start gaining energy, and once they gain enough energy, the motion between the particles will increase, and which will help to convert liquid state to vapor state. For water, this temperature, meaning for water, boiling point is 373 Kelvin. It is 100 degrees Celsius. When you convert into Kelvin, you have to add 273. When you add 273 to the 100, you will get 373 Kelvin. So you can write if you want to write in the form of a Kelvin, you can write 373 Kelvin or 100 degree Celsius. That are the boiling point of water. You can see here, when we have kept the water, we are continuously providing heat. When you provide heat, the particles of water will get enough energy, and the force of attraction keeps on reducing, which will change the state of water that is liquid to the state gaseous, that is called as steam. It will get converted into steam. Okay. Particles in steam, that is water vapor, at 373 Kelvin 100 degrees Celsius have more energy than water at same temperature. When you compare water vapor and water at 100 degrees Celsius, obviously water vapor will have more energy. We already know in ice and water, water was having more energy. The reason was it has more particles of water have more energy because it has less force of attraction. Here, water vapor gain the energy and motion of the particle increased, and therefore you can say it has more energy. This is because particles in steam have absorbed extra energy in the form of latent heat of vaporization. So, like latent heat of fusion, it was used to convert 1 kg of solid to liquid. Here also, it is a hidden heat called as latent heat of vaporization, which converts liquid to gas. The latent heat of vaporization of a liquid is the quantity of heat in joules required to convert 1 kg of liquid at its boiling point to vapor or gas without any change in temperature, and that is called as latent heat of vaporization. And latent heat of vaporization of water is 22.10 power 5 joule per kg. You can write as joule per kg like this also. Okay. Here, if you see the heat energy which is required to convert 1 kg of liquid to vapor, it is called as vaporization. That is latent heat of vaporization. see here, the bonds in the water, actually you can say the space between the water shows the force of attraction. Here the space between the particle has increased. This is the structure of gas and this is the structure of liquid, that is water. The space between the particle indicates the energy. You can say it indicates the state also. If the space between the particle is more, it will be gaseous. And here the space between the particle is little lesser, it will be in liquid state, that is water. When you supply heat, continuously supply heat, the force of attraction between the particle decrease and it will start moving randomly and with a faster rate. Effect of change of temperature. So we infer that state of matter can be changed into another state by changing the temperature. So now we come to know that when you change the temperature, solid can be converted to liquid and liquid to gas. We have learned that substance around us change state from solid to liquid and from liquid to gas on application of heat. Solid state get converted to liquid state when you apply heat, and liquid state get converted to gaseous state when you apply heat. And the reverse thing happens when in the gaseous state, when you cool it down, what will happen? It will convert it back to the liquid state. In liquid state, when you cool it down, it will get converted to solid state. So this is the effect of change of temperature. When you heat it, it will get converted to solid to liquid and liquid to gas. When you remove the heat, actually you can say when you decrease the temperature, it will change to gases to liquid. Again, when you remove the heat, that is cool down the liquid, it will get converted to solid state. Okay, that's it for this lecture. In next lecture, we'll study about few things more about temperature, and the next one, that is the second part, that is by changing the pressure, what will be the effect on the state of matter. Thank you.